Great. Okay, so let's get started then. So the course is data science for business. And so we're going to be talking about, well, how you can use data for business purposes. And without any further ado, let's jump into this. So first of all, there are some course technicalities. We'll have lectures on Friday from 6:10 to 7:30 p.m. On this Zoom, and there is a passcode here. And we do have seminars. We'll be actually running 2 sessions on the seminars, 1 session before the lecture and 1 session after the lecture. We'll put together a class website and a GitHub for seminars. And we do have a Telegram group, and I think you should all be there by now. If you're not, please let us know. We'll add you there.
So I'm not, or do we need to write it in a chat or to your email to ask?
Yes, you can put it. You can write it in the chat, or we are on the right page right now. I want to introduce the teaching team. So my name is Leonid Zhukov, and I'm professor at the Department of Computer Science. And I'll be helped by 2 wonderful assistants, is Anvar Kurmakov and Dmitry Kiselov. You can see their emails here. And Anvar, are you with us here? I think you are.
Yeah, I'm here.
Okay, that's Anvar and Dmitry. We don't have Dmitry here. Okay, that's fine. But guys, here you can see here emails at the bottom. You can send email or write into the chat. Okay. And Anvar added the link for Telegram channel right now here into the chat here in Zoom. So please join. Okay, that were us. Now I want to spend a few minutes discussing you guys, right? This class of 2023. And we did a small poll. 95 people participated out of 100, I think enrolled 118 people. And so what we see is we have 25% of our classes from Высшая школа бизнеса, right? And then we have St. Petersburg School of Business, and then 14% from Computer Science Department. And we have social sciences, economics, creative industries, law. So all kind of, faculties. And that makes, for us, the job quite interesting in this course because, there are people coming from a very, very different backgrounds and obviously with very different expectations for this course. So we'll try to balance, technical side and business side in this course. We also wanted to understand, what you can technically do because this course is about data science for business. So it's hands-on and it's case-based, which means we'll be looking into, real-world cases, working with data, writing models. So we want to understand your familiarity with Python. You sort of self-assessed, and we have, if you see here on the diagram, 42% are beginner level. There are 20% which is good familiarity, and 23% never seen Python, right? And that, in some sense, instantly tells us that, like, okay, wait a minute, we, for example, cannot just use Python as the main language for the course. We also asked about your experience with machine learning and data science. And here, picture is similar, sort of it's 50-50. So again, half of you have had courses in machine learning and data science, and half of you didn't. So we will spend some time on the basic concepts of machine learning and data science, but we'll be focusing mostly on application. Now, we actually run this type of questionnaire every year. This is the 3rd time we're offering this course. And, honestly, the picture is quite similar. The only difference is I think this year we have more people who never seen Python, but this in some sense is expected because the way technology evolves, we're getting more and more into the world of low code, no code situation where you actually, to solve some problems, you don't need to write code. Now, we want to stay current with the times. And so we ask this question: how familiar, or are you familiar with the ChatGPT, right? And 65% are familiar, which is very good news, which means you know what it is, you know how to use it. So that was an aha moment where we thought that, okay, we can actually try to use ChatGPT within this course. Now, of course, this is not going to be the main programming language, right, or the main programming system, but it will be helping us, it will be assisting us to write code and to actually solve problems. Now, of course, we're hoping that, and I mean, it's expected that probably sometime in May, we might get, Yandex Chat and Sberbank Chat, that will be capable of doing things similar to ChatGPT. Now, but for right now, that's this is sort of the next gen of AI, which is available to us, and it's not required, but would strongly recommend using it. So, taking all this into account, in this course, we'll be focusing on the usage of the program environment, which is called Orange, which is sort of data flow environment where you don't need to write code, but you connect blocks through pipes, and understanding the structure and understanding what the program should do. It should be much, much easier than writing code. But at the same time, with the help of ChatGPT, it is possible to ask it to generate code for you in Python that you can actually later on run. Now, if you're fluent with Python, be our guests. You can write everything yourself. You can also use, I guess, C, C++, Java, R, whatever you want, as long as your programs return the results and return them in the format that we are asking for. Anbar, am I correct? I guess I am, right? So we'll be happy to accept all kind of all kind of technologies that you're using to solve the problems. So what are the course objectives? Well, first of all, we want you to understand some fundamentals of data science and its relevance to various business problems and various business domains. And here they're important both sides of this. It's sort of the fact that you understand data science, you understand the algorithm, you understand the limitation, you understand the applicability of algorithms, and you know how to apply them to business problems. We want you to learn how to do this in a real world business cases. So how to take business case and set it up such a way that you can build a model for it. Use and put together data-driven strategies, and also, in fact, enhance your communication presentation skills by putting together, by using storytelling. And I don't want you to underestimate this. People remember stories. People do not remember facts. And so being able to tell a nice and interesting story, especially with data, is quite important. And so that's, roughly speaking, the course objectives. And that's what we'll be focusing on. So the course is case-based, which means we'll be looking at various use cases typical for your business. And then based on these use cases, we'll be explaining techniques, data science techniques, data science, machine learning techniques that will help us to solve those use cases. Now, this is a rough schedule for the course. We might adjust it depending on how things goes. But what we're expecting to do is the following. So this lecture, today's lecture, is really just an introduction to data science. We're going to talk about the course, we're going to talk about the objectives. We're going to have like sort of broad overview of how data science fits into the big business picture. Next lecture will be devoted to data analysis and machine learning. Again, introduction can be not very interesting for those of you who had data science and machine learning classes, but still I would recommend to listen, because I'm going to focus on the things that are important for business. And then we'll go through multiple case studies. We'll talk about pricing, the models for pricing and how you can set up price in retail and price elasticity ideas. We'll do a case study on churn modeling, and we'll be considering prediction of customer churns for telecoms. Using supervised learning, we're going to talk about customer segmentations for marketing and talk about clustering, how you can use to segment customers. We're going to talk about sentiment analysis and how it can be used in business to, for example, analyze customer reviews or do many other things. And over there, we'll discuss and talk about natural language processing techniques and the cool sort of latest stuff about large language models. We'll talk about demand forecasting, where we'll use time series analysis to predict consumer demand. Then another case study will be about personalization and building recommender systems. And finally, we'll talk about ways to do fraud detection and application to banking business and detecting fraudulent transactions using either anomaly detection, maybe graph analytics. And finally, we'll close up with, sort of again, overview lecture talking about how we can impact business with AI and how to do AI responsibly. And in parallel, we're going to be running seminars where you will have a deep dive into those techniques. You'll be given data, and you will execute and build those models. Now, we'll have some things pre-recorded for you so you can actually watch it at your convenience, and we'll have a sessions of Q&A sessions where you can ask our TAs questions. Now, textbook for the course, I would strongly recommend the book, which is called Data Science for Business by Foster Provost and Tom Fawcett. They are professors from NYU. That's probably one of the best books that talks about business and data science together, and sort of what you need to understand about business to build model and how to make your data science skills relevant for business. Plus, it goes pretty much in depth on the techniques. This book, you can actually get it online, PDFs, search for it. And there are many more books. Among other books, I would probably recommend the book on mining massive data sets that has a very good chapter on graph analytics, and it also has interesting chapters on search and on recommender systems. Very nice book on forecasting. And then there is a book on predictive analytics, which is actually just a nice read, good read. One of the sort of first books talking about how analytics can be used in business. So before we jump into the actual content, any questions?
May I ask several questions? Just concerning the organizational parts. For people who have zero experience, it is possible to get through the course and be able to complete the course. Is it feasible?
You mean zero experience in programming, right?
Yeah, zero experience in programming.
Yes, the entire point is, you notice we have 50% of the class that do not have experience in Python programming, and that's why we'll be using this data flow environment, and hopefully ChatGPT or similar chat to help you build things. So the short answer, yes, it will be possible. Now, at the end of the course, you will know how to solve some of the data science problems. This course will not teach you how to program Python, so you need special course for that. But you will be able to get through this course, without knowledge of Python.
Okay, and as I understood from the syllabus, there is no examination.
There is no exam. We'll have homeworks, and we'll also have a special project at some moment. So we can do that.
Okay.
But there is no final.
Okay, thank you.
All right, guys.
I have a question too. Can I ask her? Good
Sure.
day. It's more convenient to me to attend a seminar after lecture. So can I?
Yes.
But in my schedule there is a seminar before lecture. Can I attend the
Yes.
second one?
The answer is yes.
So there is no difference
No.
Thank you.
Yeah. So we'll keep seminars before lecture and after the lecture, because some of you has schedule conflict, and so we'll keep those two groups running, but they will cover the same material. So feel free to join whatever works for you better. Okay, so without any further ado, let's get into the topic. So, the term data science actually came to life probably like in 2012, I think, 2013, and where Harvard Business Review published this paper that says that, data scientist is the sexiest job of the 21st century. Now, before that, people who work with data in the companies were called analysts, or sometimes statisticians, but here we go. We got a new profession, right? And there's been a long discussion on like, okay, what's data scientist? Who is data scientist? And I guess the best definition is really sort of the profession is better defined based on the skill sets, which is the intersection of on one hand, computer science, understanding and being able to write programs, some math and statistics to understand what you're writing, and also some domain and business knowledge. Now, what's interesting, I think, and we're living right now in a very interesting time, unless you were somewhere in the moon, I'm sure you heard about generative AI, about ChatGPT, and all those tools that are coming out to the market. And those tools has a tremendous potential in changing labor market, in changing the way we work. And they will significantly affect the way data scientists work in terms of providing knowledge, in terms of providing additional skills, in terms of going into this no-code, low-code direction, in allowing people to actually write code, those who do not know how to write code, and writing code in natural language. So this is where we are right now, but expect a lot of changes within the next several years within the profession of data scientist due to the incoming technology. So again, typically, right now, if you come to any sort of big business, you will see different titles for people, right? You will see a data scientist who is, it's in some sense an expert in machine learning, can write programs, can build prototypes, can work with data, but then you'll have data engineers. So those are guys who are capable of actually working with much, much larger data sets and capable of interacting with databases and so on. And so in large corporations, data scientists usually work together with data engineers who are much more sort of technically skilled. And then there are data analysts. They still exist. They usually look at sort of summary of the data and quite often work with sort of C-level people and providing them some sort of general information. Again, so data scientists usually focuses on building algorithms, right? And that's what we'll try to learn in this course. So it is important for being data scientists. It's important to understand the entire process of how what you do can be used in the company, and sort of different skills, different steps you need to take to solve a problem. It's important that we're going to be starting always with a business problem, right? We're not starting with a technology. We're starting with a business problem that you want to solve. And then we'll need to come up with some analytical formulation for this problem. Let me give you an example. Let's say a client is losing, let's say a telecom company is losing customers, right? How can we analyze this, and is it possible to solve, right? The way analytical formulation for this problem would be to formulate as a churn modeling, or a prediction problem that will predict if the customer is going to churn out within some amount of time. Now, if, for example, you can make this prediction, then the solution to the business problem, which is to reduce churn or reduce sort of leaving customers, right, is if you understand that the customer is going to leave, you might come up and give some discount to this customer, or give some motivation for the customer to stay. Now, why wouldn't you give motivation to everybody? Well, why motivate somebody who is not going to leave anyway, right? It's going to be a waste of resources. So the business problem, you're losing customers, you're losing revenue. So you want to find a way to prevent that, to stop that. Analytical formulation is, okay, let's try to write an algorithm that will predict customer churn. Then algorithmic solution. Well, we need to come up with some way to predict this customer churn. And we can formulate it, for example, with supervised learning problem as a supervised learning problem, classification problem, and build a model that will calculate the probability of a churn. And then based on that model, we can try to figure out, if we want to interfere with a customer or not, with a client or not. Then when you have the solution, the next step, and again, I'm talking about, if you're working in a sort of in a corporation, in a big business, the next step is to build a proof of concept. And that's also usually the role of data scientists. So pretty much business problem, there's a business owner to this, analytical formulation that's done by data scientists, algorithmic solution done by data scientists, and quite often proof of concept is done by data scientists. The next step, after you have a proof of concept and it works, you actually try to build MVP or minimal viable product, which means a product with a sort of small number of features, but that is scale. In fact, usually MVPs are very well connected. It's connected to like databases and sort of built into the process. And then what's also very important, and that's where, again, sort of business owner comes in, you need to make changes in the business process. So, if you just make this model and do not make any changes in the business process itself, the model is useless. In a sense, it's going to predict who's going to churn, but if business is not going to react to this, like, for example, give some customer this some sort of reasonable discounts or do something else, this whole pipeline is useless. And so the point is, we're starting with business, we're ending with business. We're trying to solve business problem with a technical means. And it's very important to understand as a data scientist how far you need to go sort of at the beginning of this pipeline, interacting with the business owners, and at the end of the pipeline, making sure whatever you build is implemented and used by business. So speaking of different methods that are out there and available in data scientists, and for data scientists, I would say there are sort of four big classes of methods. So one is data mining, machine learning, predictive modeling. And that's the stuff we're going to be focusing in this course, where based on the data, we're going to be learning patterns in the data. And based on those patterns, we'll be trying to predict, either behavior or certain properties or, some other things. Predictive modeling. Second big bucket is what's called operations research or optimization. Now, extremely important for business purposes. We're not going to be talking about optimization operations research a lot here, but operations research is really about scheduling, finding optimal path, finding optimal solution. It's about optimality. Another bucket is agent-based modeling and simulations. It's usually used in the situations where it's very hard or almost impossible to put together small, simple predictive model, especially when you have interacting systems. An example for agent-based modeling would be simulation of traffic in a city where cars come randomly, and for example, simulating how intersection works or traffic patterns in the city is very hard. And that's when agent-based modeling is used, or for example, simulating the behavior of a crowd. And finally, there is a sort of, I would say, this specialized knowledge bucket where we talk about different very, very special skills and models, from text analysis, so where we can analyze text, computer vision, geoanalytics, and so there are other sort of very specialized type of models that exist. In this course, we'll talk about text analysis, about NLP, about large language models, but we'll kind of stay away from computer vision and geoanalytics. In order to cover all those four buckets, you probably need not a one module course, but 4 module course, like a year-long course. So what are the reasons for us to use machine learning within business? No, first of all, it allows us to look into the data and detect particular patterns and describe them. So for example, again, Fraud analytics, fraud analysis allows you to detect suspicious patterns within the data and prevent fraud. I'm sure you have seen or you have been in a situation when, for example, a bank denies the credit card usage and kind of marks it as a fraudulent transactions. It's the models are run at that moment of time, and if you actually making the valid transactions and the bank denies it, then you feel like, oh man, why would they do that? It's because their models are not very good, right? So third thing is detect and describe. Second is predict, and predict, of course, that's sort of the key thing here. We're trying to predict, for example, customer behavior, if somebody's going to click on an ad or not, if somebody's going to purchase something or not. We want to predict the demand. All kind of things are important for prediction. And finally, we can, if it's possible, we can explain. Now, in business, the explain part is not used a lot unless you're trying to sort of prove something, prove some strategy, or do some other sort of in-depth digging. For example, if you look at the marketing spend, you want to explain, for example, you want to do attribution, like, for example, depending on which action, what action is being used when. But explanation are very good to understand how your model works. And sometimes in some industries, very regulated, like, for example, in healthcare, you cannot use the model that are not explainable to human, right? And the same thing, for example, in financial industry, there are sometimes regulations that prevents you from using what's called black box models that are explainable. And finally, optimize and improve. Well, that works together with prediction, because what you often want to do is not to optimize current state, but you want to optimize the future. So the idea is, for example, you can predict the demand for some type of consumer goods, and then you want to run optimization algorithm, knowing the demand, knowing what the demand was going to be. Now you can run optimization algorithm to figure out what, for example, the best routes or the right amount, the right quantities of goods that has to be delivered. So all this works together in real world settings. Now here is a simple example showing like sort of the differences. If you think about statistical analysis, where we talk about measuring and understanding, well, here is the data points. Let's say we have some input, we have some output, and here is those crosses. These are like data points. Now, predictive modeling would allow us to interpolate between those points, finding patterns, right? Predict the outcome. And in this simple scenario, connect input and output for any types of for any values of input, right? Though initially we had only 3 data points. And so it allows us to draw this nice smooth line. Now, optimization would mean, okay, within this smooth line, let's find the value of input that gives us maximum output, right? And that is optimization problem. So again, in this course, we'll be focusing on predicting outcomes, but keep in mind that a lot of algorithms that we're using, they can be used to sort of measure and understand the data, and later on, you can use output of our predictions to do optimization, because again, business is interested in optimizing the future, not the current state. So use cases. Data science used across multiple industries and in many, very, very, very many cases. I listed a few of those here. If I was thinking about, say, consumer goods, which is typically we were talking about like retail. Here, the sort of the most fundamental problem is demand forecast, right? You want to predict how the customer demand, and based on that, you will fix or improve your supply chain, right? Because you need the right amount of goods in the right place in the right time. And so demand forecasting plays a key role in there. Looking more on the customer side, we can think about personalization, where we talk about, okay, how we can actually do a personalized offer to people. And in fact, a lot of this done, say, on the web almost automatically, because the ad they're showing you depends on your previous behavior. Well, you can use the same type of model in a regular sort of brick and mortar store. Another idea is about pricing and promo effectiveness. That's where you actually calculate the right pricing, and you analyze by doing promotions that reduce prices. You eventually want to sell everything to maximize your store revenue, right? And how do you actually optimally select promotions to maximize your revenue? Now, assortment optimization means what kind of assortment you want to put in different stores, right? What's interesting for your customers locally. Cross-sell and upsell, this is the idea of recommendation systems, where if somebody buys product A, what product offered to a person, and maybe offered some discount. That's sort of for consumer goods. If we think about telecoms, then there is some other type of problems there. Well, next best offer is, if you're in a plan or using a particular device, what device to offer you and at what price, sort of where the probability the highest that you're going to buy it. Second is churn and retention modeling. This is a prediction, as we discussed before, the prediction that the customer is going to churn out or leave your service. Network optimization, well, this is a more technical problem, trying to figure out where to put, for example, towers, telecom towers. Capacity utilization is, again, how your towers and how your sort of network hardware is being used and utilized. Banking finance, well, of course, there are some problems that are very, very much associated with banking. It's credit risk assessment or credit scoring, right? Giving you credit or not, and if you're giving at what rate. So the probability of default. Fraud detection is also extremely important in banking. Claim management is support of customer claims, and churn and retention, the same way as in telecoms. And the reason here is, in service companies, like telecoms, banking, consulting, clients are extremely important. It's the clients are hard to acquire. It costs a lot. And so that's why those companies actually try to protect the customers, try to keep the customers. And that's why those companies want to know if the customer is want to leave, right? Because they're willing to do something about it. If you think about regular stores, they don't care. Too many customers, very easy to get a customer. It's much harder for banks and telecoms due to all the competition they have. And then on the right-hand side of the slide, there are topics how we can use machine learning and data science within more of sort of industrial topics, right? So industrial goods, we're talking about factories, about manufacturing, and you can think about optimization of the manufacturing process using data. Also demand and supply forecast, because supply chain, of course, starts quite often within the factory. Planning of operations, and predictive maintenance. Predictive maintenance, that is how we predict that equipment is going to fail. Energy efficiency is also optimal use of energy. Notice, by the way, that here there are quite a lot of optimization involved. Energy, the same thing, logistic optimization, production optimization, optimizing risk management, and overall for typically any enterprise we have, there is all kind of back office automation, or RPA, robotic process automation. So ways to actually make the back office work more efficiently with the help of software, and all kind of workforce planning and management. So in this course, we're going to be focusing on the left side, which is more of sort of B2C cases, sort of it's consumer goods, telecom, and banking use cases. Several reasons for that. One reason is, typically, and I mean, there are much more business, and especially, if will be looking for a job, you most likely end up either working for consumer goods company, telecom, or banking, rather than sort of, energy or industrial good company. And there are more data available for those type of use cases, so we can actually build models for those use cases. It's actually a little easier to understand what's happening there. And also within industrial goods and energy use cases, there are quite a few optimization problems. And so, as I mentioned before, we're going to be focusing on prediction, on predictive problems, on machine learning. We're not going to touch optimization in this course. So, machine learning prediction. There are three types, or broadly speaking, three types of machine learning algorithms that exist out there. So the first type is unsupervised learning, and this is the way to understand, to detect patterns in the data, to discover structure in the data. And that type of machine learning is done by algorithms themselves without human intervention. We don't need so-called target variables. The second class of machine learning is so-called supervised learning, where we aim, using the data, we are trying to predict some sort of target. That has to do, like, for example, if the customer is going to churn or not, if somebody's going to buy thing or not. And within supervised learning, it's usually either regression type of modeling, where we predict numbers, or it is classification, where we detect classes. For example, taking a picture and saying if there is a human in there or not. Finally, there is a big class of problems which is called reinforcement learning. They usually have to do with optimizing action for independent actor, or for robots, for self-driving cars. So it's usually used for this type of autonomy. Now, what we're seeing right now is this emergence of new approach to machine learning through what's called large pre-trained models, that in fact combines version of unsupervised learning, which is called self-supervision, which can be where a model is trained on a very large data set, again without humans, and then with a bit of supervision with a human data. So things are changing, but classically, this is sort of the picture. In this course, we're going to be looking into unsupervised and supervised learning as examples. We'll stay away from reinforcement. Now, within supervised learning, as I mentioned, there are sort of classification algorithms, there are regression algorithms. In classification, we predict classes. In regression algorithm, we predict numbers. There are also a ranking type of algorithm that allows us to rank items. And sort of typical examples, there are a lot of algorithms, both classification and regression, but you'll hear a lot about decision trees, about random forest, about neural networks and deep learning. We'll hear about linear regression, regression trees, and logistic regression. Now, logistic regression, in spite of the name regression, it's actually classification algorithm. And for unsupervised learning, there are also a bunch of algorithms that are out there that are sort of classical machine learning algorithm that are clustering, like k-means or spectral, which is a way to detect groups of data points that are sort of closer together than between themselves than from others. The ideas of so-called dimensionality reductions, principal component analysis, are ways to actually reduce the size of, say, representation for the data point, and anomaly detection, where we're trying to detect outliers in the data or data points that look very, very different from others. Now, for those of you who had the class in machine learning, like for those half of you who had the data science and machine learning class, this is sort of repetitive, right? And you have seen this, it's probably a boring topic. For those who never had machine learning, this is, very, very, very sort of high level, very quick overview. But we'll talk about each of those techniques, each of those approaches and algorithm during the course, picking up a sort of single business use case and using an particular algorithm to solve it. So, but as a sort of outcome of this slide is that there are two classes of algorithms, supervised and unsupervised. In supervised learning, we try to separate data points based on some training information, and unsupervised, you try to find patterns in the data. Now, speaking about sort of overall modeling pipeline, you typically start with data understanding, and you cannot underestimate that part of this modeling pipeline, because if you don't understand what's in the data, don't start programming. You want to check the quality of the data, see what's in the file, actually sort of eyeball it, make sure you have zeros where you think there are zeros, you have characters where you think there are characters, etc., etc., etc. Then you prepare the data. You can clean the data, you put the right format, you can probably aggregate the data to perform what's called ETL process, which is extract, transform, load. Then you actually try to build the model. And when you build the model, you evaluate the quality of the model. Now, honestly, I don't remember a case when the model would just work right away, right? So typically, models do not work right away. So, you kind of iterate. It either doesn't work well, or doesn't work at all. So you go back to data preparation and sort of go in circles until you actually until the model actually works. Then you do model evaluation, and we're going to talk about ways of doing it. And that's a very important part, where you analyze the quality of your model, and without that you would never ever deploy it. And finally you deploy it, which means putting it into production. Now notice there's a lot of sort of back arrows, because quite often when you do the model evaluation, sort of independent evaluation of the model, you realize that it doesn't perform the way you want, and so on sort of independent evaluation. And then you actually have to go back. You either go back and try to redevelop the model, or you go back and try to change the data, or you might realize that you missed some facts about the data, and you actually need to go back, way back, and try to understand what data is. Now, if you are sort of an independent data scientist, that is the pipeline you're working with. You start with data, you end up with a model, and the model deployment is usually done either by data engineers, or you hand it over to sort of business owner, and you can go for the next model. If you are, on the other hand, part of big organization, then the process changes significantly, because you all of a sudden you get a lot of other people involved. And in fact, in large organizations, you will never be able to just deploy yourself, your model, to any production facility or any customer facility. Well, again, unless you are a startup, right, where you do whatever you want. So here, there'll be more steps, and the steps will be in terms of interacting with other people. So you collect data, you build your solution, but then it's not you, it's IT people who would be able to who would be deploying it. And so you need to prepare a solution for IT guys, and that can be a lot of painful process. And then after the model is deployed, there should be some changes in the business process, because business should learn how to use the model. And finally, again, if you are working at a large company, you need to deploy this at scale, which means, let's say you're working at a large bank, and there are offices of the bank, many thousands of offices of the bank. And if you have your new solution, you deploy it to the one office, but then it has to be deployed at thousands of others. And so that is usually done by IT guys and business owners, but you as a person who built the model will have to sort of follow through, because all the questions regarding the model performance will be coming back to you. So, building data science models, deploying them in large organization is a very, very challenging topic. So finally, last thoughts on this overall sort of data science and business. Now, of course, without algorithms and models, we cannot do a lot of things. But when we go and interview data scientists, interview business owners, look at how much time and effort being spent of doing different parts of that pipeline in a real business situation, we actually came to this, 10, 20, 70 rule that in fact, 10% of the value, probably 10% of the effort goes into building an algorithm, developing algorithm and analyzing data. 20% goes into building technology around it and actually sort of industrializing algorithm. And 70% of effort goes into changing the business, into changing the way people interact with this algorithm, they use it. So it is called change management or enablement. And you actually have to redesign the process and make people use what you've done and use it correctly. Now, that might look like a sort of strange numbers, right? Because as a why would we do like data science if it is that way? If data science is only 10%. Well, without your algorithm, we will not have this 20 or 70 at all. It just tells you that, in fact, as a data scientist, you're part of a much larger system that includes technology and IT, and that includes a lot of business decisions. And so yes, without data science and models, the rest will not exist. But if you look at the overall the effort, what it takes to build things and deploy them within the large organization, it's really that 10, 20, 70 rules. And that's something I want you to keep in mind when you build your products. Again, this is not applicable to startup where you can do everything yourself and there is no big organization. But in large organizations, bureaucratic, large, complex organizations, which a majority of the large companies are, that is the rule of the thumb. And with that, we're done with our first lecture. I hope it gave you an idea of what the course is going to be about. We tried to touch in this lecture all kinds of topics, and we're going to be diving into the machine learning and data science on the next lecture. With that, I'm done. Questions, please.
Yes, I have questions, please. I rightfully understand that we will do some machine learning algorithms, including NLP, time series, etc., on seminars.
Yes, that is correct.
That's great. Thank you.
Any other questions, guys?
Will we
Okay.
receive this presentation?
Yes, absolutely. The presentations will be available right now. We'll put them into the Telegram channel, right? And then, we'll have both presentations and video recording available both through Telegram and on the site for the class that we're going to put together. Now, having said that, I strongly encourage you to come to the lectures and seminar discussions, because otherwise it's very boring for us to do this if you just prefer to watch lectures pre-recorded.
Okay, of course. Thanks.
Anything else?
Can I ask, please, which kind of data we're going to analyze, if it's possible to say?
We'll be using data like publicly available data sets. Most of them are taken either from Kaggle, which is a data science computation site, or collected somewhere else from the net. Depending on the use case, we'll be looking into the sort of financial data, or we'll be looking into telecom data, or sales data. Again, this is all, as a rule, this is anonymized data taken from prepared for some sort of competitions or other type of examples.
Thank you.
Also, I'd like to clarify if we shall work only with table data such as pandas, data frames, or with graphs and other difficult types.
We'll start with table data, right? Because majority of, say, transactional data, this is table data. There will be a lecture on, and this is structured data, right? Then we'll have a lecture at some moment on sentiment analysis, where we're going to be analyzing, reviews, sentiments of the reviews. and that is text, unstructured data. We're going to work with text then, and probably that sort of depends on how fast we go, right? We might work a bit with a graph data, looking into transaction and anomaly detection.
Thank you.
All right. If there's no more questions, nice meeting you guys. I'll see you in a week.
Thank you. Goodbye.
Thank you. Goodbye.
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 Thank you.
Goodbye.
Bye.
Thank you. Goodbye.